Hello students, today we are going to do exercise 2.2 fractions and decimals. A few questions of this exercise. So first question is 2 into 1 by 5. How to represent it? So student 2 multiply 1 upon 5. So as a fraction is a part of a whole or a part of a group. So a group of 5. So first of all we have to make a group of 5, 3 and 4, 5. 1 2 3 4 and 5, and we have to choose one. So choosing one or shade one part, one of the circle, shade one of the circle, you can circle any of these, and two times means total two groups. So leaving this, similarly is done to 3 into 2 upon 3. So fraction is 2 upon 3, and 3 times of it means we have to make three groups, and in we can divide it each into three equal parts. Okay, dividing each of these circles into three parts and shading to one part and second part from each, again because we have three times of it. So again shading one part and shading second part of the second, shading one of the part and shading second part. So this part is 1 upon 3, 1 upon 3 and 1 upon 3. So total 1 upon 3, 1 upon 3, 1 upon 3. So 3 times, sorry, 2 upon 3, 2 upon 3 and 2 upon 3. So 2 upon 3 how many times? 3 times. Similar students here 1 upon 5, because one of the circle is shaded. Here it is 1 upon 5. So 1 upon 5 how many times? 2 times. Similarly students 1 upon 4. This time 1 upon 4 means we have to divide one of the circle into four equal parts and shading one of any one of the part. Again dividing this circle into four equal parts and taking any one of this. Again dividing a circle into four equal parts and taking one part of it. So total number of parts in the right in the denominator and shading one part. So 1 upon 4. This is also 1 upon 4, and the third one is also 1 upon 4. So 1 upon 4, 1 upon 4, 1 upon 4. How many times? 3 times. So 3 into 1 upon 4 is represented by this. Now second question is done. Multiply and reduce to lowest form and convert into a mixed fraction. So is done how to solve. So taking first question, 7 multiply 3 upon 5. So how to solve it? So student, the multiplication of fractions is done as, if 7 has no denominator, we can place 1 in the denominator of any number. So this can also be written as like this, 7 upon 1 into 3 upon 5. So in multiplication is done, never take LCM, directly multiply numerator to numerator and denominator to denominator. Now 7 into 3 21, and 1 5 0 5. So this is improper fraction is done. This fraction is called improper fraction. Improper fraction means when the numerator is greater than the denominator. Here 21 is greater than 5, so it is an improper fraction, and every improper fraction can be converted into mixed fraction. How? By dividing. So if we divide 21 by 5, so 5 4 is 20 and the remainder is 1. So 21 upon 5 can be written as, first of all we write the quotient and then remainder in the numerator and 5 in the denominator. So whole number 4 plus 1 upon 5 can be written as 4 and 1 by 5. So 21 upon 5 can be written as 4 and 1 by 5. Similarly then let's solve one more question. Taking question number 6, and the remaining question is done, you have to solve yourself. So this question can be written as 6, can be written as 6 upon 1, because 6 has no denominator, so it can be written like this. Now multiplying numerator to numerator, 5 and 6 are numerators, 2 and 1 are denominators, so multiplying them in the denominator. Now student here if any of the number in the numerator and denominator comes in the same table, so we have to divide them by the same number. Like here 2 and 6 both are divisible by the table of 2, therefore dividing this 2 by 2, 2 ones 2 and 2 3 is 6, because both the numbers are divisible by 2. Dividing by 2. So student, if both the numbers are divisible by the same number, we have to divide only then, otherwise we have not to divide. Now in the numerator we have 5 and 3, in the denominator we have 1 into 1. Now in the numerator 5 3 is 15, in the denominator we have 1. So whenever there is only 1 in the denominator, no need to write. So 15 upon 1 means 15. So similarly student, you have to solve the other questions yourself of question. Now comes question number 4 student. You have to shade 1 upon 2 of the circles. First of all, 1 upon 2 means there are a number of circles here, 3 3 3 3, totally 12 circles we have, and you have to divide 12 circles into 2 equal parts. So if you make 2 equal parts, so in each part you will get 6 circles, and you have to shade one of the part. So out of these 12 circles, it means you have to shade half parts. 1 upon 2 means half. In the second, so 1 upon 2, first of all you have to divide these circles into 2 equal parts. So in each part you will get 3 and 3 circles in each part, and you have to shade one of the part. So it means you have to circle, you have to shade 3 circles. So you will do it yourself. Now comes question number 5 then. Here you have to find 3 upon 2 of 24. So whenever such type of question is given to you, remove the of and multiply. So 3 upon 2 of 24 means 3 upon 2 multiply 24, and do it the same way. 24 can be written as 24 upon 1. Now how do we multiply fractions? Numerator multiply numerator and denominator multiply denominator. Now students, 2 and 24 both are divisible by 2. So 2 ones 2 and 2 12 is 24. Now in the numerator we have 3 and 12, and in the denominator we have 1 and 1. Now 3 12 is 36, and in the denominator 1. Now students, whenever there is 1 in the denominator, no need to write it. It means 36 is the answer. Similarly student, we can also solve 3 upon 2 of 46. So 3 upon 2, remove the of and multiply 46. So 46 can be written as 46 upon 1 because it has no denominator. So multiplying numerator to numerator and denominator to denominator. Here 2 and 46 both are even numbers, so divisible by 2. So 2 ones 2. And if we divide 46 by 2, we get 2 2 is 4 and 2 3 is 6. So 23. Now in the numerator we have 3 and 23. And in the denominator we have 1 into 1. So 23 3 is 69 upon 1. So the answer is 69. Now similarly student, you can solve this question yourself. 2 upon 3 of 18 and 2 upon 3 of 27. So solve these questions yourself student, and practice more and more, and do the homework also. So till then, thank you.